Now, once we find the longest carbon chain, the next thing that we have to do is figure out which end to number from. So remember that last example that we looked at? We said, let's number it this direction here, because that gave us the most substituents. So that's our first goal, is just to find that longest carbon chain. All right, so now what we need to do is we need to figure out, do we number it, for example, up here? So do we start here, or do we start here? That is the question. Now in each case we still have 4 substituents. So let's number. So this is 1, 2, 3. So this would have a substituent at number 3. And then this is 4. So it'd be at 3 and 4. And down here we're at 5. So 3, 4, 5, and 6. 3, 4, 5, and 6. Now if we number it down this direction, we get 1, 2. So we get a 2, and then a 3, and then a 4, and then a 5. So comparing these two sets of numbers, I think you can see pretty quickly, right? We have a 3, 4, 5, 6, and a 2, 3, 4, 5. It's the first number that we are concerned with. So we're not doing any weird math where we add up the numbers and get the smallest sum or something like that. The fact that 2 is less than 3 means that we want to number it just like this. Now, rule number 3. Once we figure out longest carbon chain, that's rule number 1. Once we've determined which end to number from, that's rule number 2, then we simply add the substituent names. Now, when we look at this, let's number it. So this is our carbon number 2, and our 3, and our 4, and our 5. Right here we have 1, 6, and 7. Now, when we look at our substituents here at number 2, this group right here, that has 1 carbon. It turns out to be a CH3. And with 1 carbon, it's meth, right? And then as a substituent, we add il. Now we can't just say it's a methyl. We need to have a number, a locator. So that one is at number 2. So then coming up here at number 4, that's another methyl here. So both of those are methyls. And that's at 4, so that's a 4 methyl. And then over here we have another methyl here, and that is at number 5, right? 5 methyl. All right, now this guy here has 2 carbons. It's a carbon connected to a carbon. Right? It's a CH2 and a CH3. So 2 carbons equals eth, right? And then we add il on there because it's a substituent. And we note that it's at number 3. So then putting that together, the other substituent is a 3 ethyl. Now we're just about done. So we want to try to reduce redundancy here a little bit. So we don't need to say it's 2 methyl, 4 methyl, 5 methyl, because they're the same. So we're going to combine those 3 methyls into 1, and we're going to call it tri, because that's 3, right? So di for 2, tri for 3, tetra for 4, right? And you could go on to penta. You're just not going to see that very much, though. So di, tri, tetra, most common that you'll come up with. In front of the substituent name. So we have 1, 2, 3 methyls. So that's going to be a tri methyl. Now we know, by the way, with 7 carbons, remember that the parent here is hept and it's an alkane. So we can't just say it's trimethyl heptane because you don't know where the methyls are. So you have to say specifically where each one of them is. So what you're going to do here is you're going to call this a 2, 4, 5 trimethyl. And then the other group is an ethyl group, and that was at number 3. So a 3 ethyl. Now, what we're going to do is we're going to put these in alphabetical order. So we're going to do that. That's the last thing that we're going to do here. Now, when we do that, it's not the T that counts. It's the M of the methyl that counts in this situation. So the methyl counts, and then the E here counts for your ethyl. So then putting all of this together in alphabetical order, ethyl, right, E beats M. So this is a 3 ethyl, 2, 4, 5 trimethyl, and then the parent name here, heptane. And there you have it. Now, the investment in learning your nomenclature right now is that once we spend time and we understand all of these rules, the rest of the whole year is based off of these rules. So when we get into naming, for example, carboxylic acids, the nomenclature is half of a page. It's really straightforward because the same rules apply. It's just that the suffix changes. Now, the last little sub rule that we're going to talk about, there's two really, is the substituent location tie. So if you get a tie in the substituent location numerically, then the substituent that has lower alphabetical order is given the lowest number. Right, so when we look at the structure here, that is your parent. So that is 8 carbons, right? 1, 2, 3, 4, 5, 6, 7, 8. And we have substituents going from, if we number from the left in this red numbering, we have something at number 3, and we have something at number 6. If we number it going this direction, you'd have a 1, 2, 3, 4, 5, 6, 7, 8. Right? So then you would have a substituent at number 3 and number 6. So there's a tie there. So the question is, what do we do? So again, it's the substituent that has the lower alphabetical order that's given the lowest possible number there. So for us, what are the substituents? Here we have, remember, 1 carbon equals meth, and then we add il on there. Here we have 2 carbons. So 2 carbons is an eth and then an il. So alphabetically, ethyl comes before methyl. So it's this red numbering that we'd want to use here. So the name of this thing would be a 3 ethyl, 6 methyl, and I ran out of space here, but this would be connected octane. Now, if the branches are tied in their name, then we just step in and we look for the first point of difference. Right? So in this case, this is the last little subset that we're going to look at. Right here we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is known, and it's an alkane, so it's a nonane. And I think you can see pretty quickly without going through it, right? We get a number 3 this direction, and if we count it going that direction, that would put this at number 3. And the other thing is that these are ethyls. So both of these are ethyls. So we have a tie in our location and a tie in the name. But if we step in going with our red numbering here, right? This would be 1, 2, 3, 4, 5, 6, 7, 8, 9. With our red numbering, what we end up getting is a substituent at number 3, and then 4, right? And then number 7. Our blue numbering gives us a substituent at number 3, right? Number 6, and number 7. So we have a tie here, but we break that tie when we look at the next number, 4 versus 6. So this is the numbering that we want to use. So then putting the name of that all together, putting all those elements together,